Yeah, hello everyone, and welcome to another edition of today's program. I know we've been drilling you guys since 12. It's fine. I'm happy that I've got you see my face again. I'm sure that every one of us is happy, and we're getting a lot of stuff to take. We're giving you a lot of stuff to take home. I'm really happy that you guys really had the patience to stay with us to this time. So now we're going to be having Mr. Raj and for artificial intelligence and MI. But before we bring Mr. Raj up, we're going to bring Benedict. Benedict is from Ghana, and he's going to talk to us, give us a few points and stuff that we need. So just listen to Mr. Benedict, and we'll have fun. So I'm going to bring Mr. Benedict on board. Hi, Benedict. You're live.
Hello, Jerry. I
Yeah.
hope we are all doing well. Yeah. Okay. And my name is Benedict Amako, and I'm a robotics coach. I've been judging at the first level league in Ghana for the past 2 years. So it's been really interesting getting to get that experience. And before that as well, I've been working on a lot of competitions in Ghana. If you know a lot about robotics competition, I was with the ladies who represented Ghana at first them from Mexico as well. What I'm on here to do today is just to give you some pointers on how robotics you can be actually successful in robotics in Africa. I'll be using Ghana as my main focus because a lot of my experience has been from working with Ghanaian teams, working in Ghana, and comparing it to the kind of experience I see out there, and from my experience in talking to people at these global competitions, been to African competitions and international competition. I realize there's a little bit of a gap in there. Okay, so with the when you go for these international competitions most of the time, you realize that it's very free and open. It's more about the fun than the technical aspects and all these kind of things. And sometimes in African competitions, is a fight between ourselves, which mostly is not the best. However, what I'm here to do is let you see how we can bridge the gap and look at how we can have that kind of success in our kind of robotics competitions. And before I go on to talk about my specific points, I'd say that the success is something you define yourself, because you are the only person who can know that I've reached a point where I feel like I'm a bit successful in here. You get me? So once we go in here, I just want to say that these are a few pointers I noted down from my experience and for my about 4 years of robotics coaching, about 5 years or more of my robotics career. I'd like to say it. I'm still in school, but this is what I've noted down. I realized that the first thing that really drives everyone should be your passion. Okay, so most of the time we realize that it's our passion that will make us reach where we want to go. Okay, so because I've been doing robotics for some number of years, and sometimes it feels like, okay, so let's move on to the next chapter. But then the thing is, if you have that drive and passion, okay, the thing is, you are going to keep going at what you need to do, and there's not going to be a defining point for you. There's always going to be a level you reach and you want to go higher. Okay, so you need to understand that you should when you realize that you watch a robotics video and are so excited about it, you realize that there's a yearning to do more, and you want to have that kind of passion. And the first thing about robotics to be able to be successful is passion. Okay, another thing as well is you need to find a group of passionate people. Most of the time you realize we see these people doing a lot of robotics and outside there and they're doing big stuff. The thing is, they have a lot of people who are passionate around them as well. So with there, when you work in a team, you're able to share ideas because helping each other is the way to go to be able to reach that kind of success point. So you need to work in a team. Okay. The next thing is you need to gain the skill, because I like to say that passion without skill is a bit useless, because you cannot do much with just having the passion. You need to be able to develop the skill, and it's really important to invest in it. Your parents Okay, okay. So I think my time is up. My time is up. Um, my time is almost up. I think I just have about a few minutes. The last thing I'd like to say is that when you fail, okay, it's very important to fail. When you fail, be sure to bounce back. Okay, be sure to bounce back. Don't ever let failure be a defining point for you. Once you're done failing, get up again and then try to move forward. Okay. So, in to be able to ginger a lot of students in Ghana, I started a robotics academy. Okay, so I don't have time to talk about it, but if you're interested in learning more of what we do, academy called Rotech Academy, you can always sign on to have an info session. Okay, a link. I think Jerry will post the link later, and then we'll be able to explain to you what we do and how we can help you. We can help you push in your interest in robotics and also do more in Africa because we are all about helping students to be able to do more. Okay. Thank you very much.
So thank you, Benedict. Um, we'll be bringing on Mr. Raj on board now for AI. So stay tuned. Mr. Raj,
Yep.
yeah, you're
Hi.
live now. Hi, sir. You're live.
Hi. Hi, Jerry.
Yeah, sure. Thank you.
Good afternoon.
Good afternoon.
Okay. Hello, everyone. Hope I'm audible. You can ping if I'm clear and loud. Are you able to hear me properly? Hello. Are you guys able to hear me properly? Okay, great. I got your response. Thank you. Hello. Hello.
We can all hear you, sir. You can go on.
Okay. Okay.
Yes, just
Perfect.
go on. Yeah.
Yeah. Perfect. Great. So, good morning, good evening, good afternoon, guys. And I hope your day is going very good and you are enjoying to learn different session including Python and other sessions. So my name is Rajesh again. For them who has joined first time, they missed last session. So I am data scientist working for Ford Motor Company here at United States of America, and my little bit background about me is I'm from India, and I did my masters in statistics and PhD in statistics, and working in industry from last 12 years. Okay, I'll go in presentation mode. Great. So what you will learn here. So in previous section, we learn about brief about artificial intelligence, machine learning. So in this session, we will just recap what you learned in last session, and then we'll talk about little bit about basic statistics, what is central tendency, correlation, regression, hypothesis testing, and inferential statistics. So these are the tool that we should be knowing if we are going to build any machine learning algorithm or any AI application. That's a very, very fundamental and basics that we should be knowing. And we'll also talk about probability theory, and we'll do some hands-on experience also. We'll go to Python coding and whatever we learn, like center tendency, how to calculate the mean, how to calculate its standard deviation, correlation, regression. So we'll do some coding as well, and we'll just use one data set and try to do all the exploratory data analysis. We'll plot some graph also. So basically, this is basically we are going to build a foundation to develop any model. Model means machine learning based model. Okay. And in next session, we will be building actual regression model using linear regression model using Python. And also, if time allows, we will be building a tree-based classification model, that is decision tree, that we will cover in next session. Okay, so just a recap from the previous session, we learned artificial intelligence, brief about artificial intelligence, what exactly it is, and why everyone is focusing, why everyone is talking about artificial, why it is too hot topic nowadays. So, and we also discuss some of the very live use cases, like how we are using artificial intelligence in our day-to-day life, including on social media, e-commerce website, like while buying any product from Amazon or Flipkart or eBay or any other, or Alibaba or any other e-commerce website, and how we are using artificial intelligence in manufacturing plant, how it is helping to increase the production drastically, how we are using artificial intelligence in transportation system, how we are using artificial intelligence in telecommunication, and how we are using artificial intelligence in healthcare. So in different and various domain we are using, and we will discuss few of the use cases, uses. So what is artificial intelligence is basically the power of machine to copy intelligent human behavior. It's a combination of science and engineering of making intelligent machine, especially intelligent computer program. Basically, it's modeling human thinking, what you think, how you can convert your think, your thought, your process, your idea into a system, into a application, or into a machine, so that your machine can do your job. Then we talk about little bit about um, different tools of artificial intelligence. That is, we talk about two type of artificial intelligence: artificial narrow intelligence and artificial general intelligence. And then we focus on artificial narrow intelligence mainly. All the real life example nowadays we have and we are using in our society all belongs to artificial narrow intelligence. We also discuss what is machine learning and data science, what is the difference between machine learning and data science, what is deep learning, how it works, supervised and unsupervised learning, and then some buzzword like semi-supervised, reinforcement learning, knowledge graph, etc. So we will be focusing for supervised machine learning. And to build that idea, that knowledge, we have to build base in the sense to we should be having a good understanding of statistics, basic statistics, inferential statistics, how we can summarize the data, that is exploratory data analysis, and some idea of probability theory also that we will be using in supervised machine learning. We also talk about machine, what is machine learning. So it's a basically field of study that gives computer the ability to learn without being explicitly programmed. Machine learning comprise a large number of algorithm, means supervised, unsupervised, semi-supervised, and within supervised we have so many different algorithm like random forest, decision tree, linear regression, logistic regression, all comes under machine learning. So it depends on use cases, depends on our requirement. We select the best algorithm suits to our data and our objective. That is the very key, how we can select the best algorithm that suits our data and our to meet the objective as well. Then we talk about difference between machine learning and data science. So data science is basically just extracting some knowledge from the data, and that is helpful to take some business decisions. Machine learning is also do the same thing, but instead of just one time, here in machine learning we build some kind of application to use that on a repetitive basis. So like we develop one app, we build a regression model, and then we implemented and created a mobile app so that anyone can use anytime. For example, uh, we have a data of housing project. So for example, last time we give an example, like for example, here you can see we have one variable is size of the house, and we want to and number of bedroom, and we want to predict the price. So it's A to B mapping. A is different exploratory data variables, and B is our dependent variable. We can call it dependent variable and independent variable. So dependent variable means which we are going to predict, and independent variable is variables that we are going to use to predict dependent variable. And then so we have the data, we understand the data, we understand the pattern of the data, and then we build an algorithm and created an app. So whenever in future anyone is entering the size of the apartment and number of bedroom of the apartment, they will get the price automatically. So no need to build again the model is already built, everyone is using, and that can be used with many persons. So that is data science. Then we talk about let data, structured data, unstructured data. So structured data means anything that we can collect and store in a tabular format is a structured data. Like here in this example you can see is size of the house, number of bedroom, price, etc. Unstructured data comes like images and text and audio. So these comes under unstructured data. And dealing with unstructured data is completely a different animal. We have to convert unstructured data into some numeric in numbers, then we can use and build some model. So we'll focus on structured data first. Okay, so that's enough about previous session recap. Okay, so here we talk about types of variables. So in the previous slide, you can see the size of the house, number of bedroom, and price. So these are what exactly these are. So this is nothing but different type of variables. Okay, so these are the variables. This is one variable, this is another variable, and price is another variable. It can be a different type. Like in this example, we have all are the continuous variable. It can be a categorical variable. Like for example, here if we also interested to see the location where this data comes from, what is the location, means city wise, because the price will definitely depend on the location. If it is a big city, then price will be more compared to a small city. uh, Again, and many more variable that we can add, we will look at while building the model, the different variables and how to deal with the categorical variable and numeric variable that we will learn while building the model. So on high level we can divide the variable in two different type: qualitative and quantitative. Quantitative means when we have some numbers, like for example, age, weight, temperature, number of bedrooms, and uh, area of the house or location. So we have some numbers that we call it as a quantitative data, and qualitative data that we have some categories, and that also we can look at categories that explain some quality. And this can also be divided into part to type, like nominal data and ordinal data. Nominal data means unordered, there is no order. Ordinal data means we have some order. Like for example, if we have one variable that is showing that low, medium, high. So here we have some order. Like for example, uh, if we categorize the student in three group, means very bright student and okay type student and student are not performing well in three category. So that comes in order. So different type of order that we can look at, generally low, medium, high, high and low. So different type of order that we can look at, and we have to deal these data in a different way while building the model. Okay, so everything is around statistics, mathematics, and computer science in machine learning. Statistics is a base, means we should be having good understanding, at least a basic understanding to start thinking about machine learning and data science. So what is statistics? So it's a basically science of collection, presentation, analysis, and reasonable interpretation of data, and using that we make some decisions, some business decisions. Now we can divide the statistics in two parts: descriptive statistics and inferential statistics. So descriptive statistics means summary of the data, uh, that that is basically measure of center tendency, measure of dispersion, measure of skewness. Summary of the data means what is the average value of the data of any specific variable, and what is the shape of your data, and how disperse is, means what is the variability, how your data is behaving. It is very very zigzag or very very smooth. Can you see some pattern or you cannot see any pattern? So that comes under measure of dispersion or variability. And then inferential statistics is basically method that use sample result to help make decision or prediction about the population. So last in last session also we discussed uh, how we can draw a small sample from the large population, and then do the analysis for a small sample and propose that if it is working well, so we can assume that the result whatever we got from the sample, it will replicate or it will mimic the same thing for the large population. Okay, so that comes under inferential statistics. So here we have to decide, we have to use some kind of a statistical algorithm to prove that whatever difference we can see, like for example if we are testing two type of test, so while looking from the descriptive statistics we can see mean of one treatment is more than mean of other treatment. Okay, but that may not be statistically significant. So there is another terminology comes in picture now, statistically significant. So while looking at the data we see some difference between one group to another group, but that may not be true in general. The difference we see that may happen by chance. So we have to statistically prove that that difference is not just by chance. This difference is because of some external factor impacting your analysis. Okay, so measure of center tendency, it comes like, let's talk about the central value of everything. I'm sure that you guys are aware with mean, median, mode. So mean is just summing all the observation and dividing with number of observations. So like here in example we have 20, 30 and 40 and total 3, so we divide by 3 and we got the mean. Median is we select the middle value in order sequence. So if we have odd like 1 2 3, here 3 element, we were having 1 2 3 5, like in this case, like here if you see we have 3 element, so we need to select the mid one. But we cannot just select directly as it is. First we should sort out. So we will arrange, sorting is means arrange this data in a sequential order. So we'll rearrange this. This will become like this, means 3 5, then 6, and then 7 9, and then select the mid one. Okay, that will be our median. Now the question, if this was fine if we have the odd number of observation like 5, then we can select. But what if even number of cases, like here we have 6 observation, then how we can select the mid one? We have the 2 mid one. So again the procedure will be same. We have to arrange this data in a sequential manner and then select mid 2 and take the mean of these two. That will be our median. Okay, and mode is the most frequent value in your data. So like here in your data 2 3 4 5 1 2 3. So here the most frequent value is 2, so mode is 2. And in different situation we have to use different statistic. These are the basically we can call it statistic and from sample. So suppose this was the population, we draw some sample from this population and we calculated the mean value of this population, and then we can say if the mean value of this population, this sample is this much, so we can assume that the mean value of the whole population will be almost similar. Okay. Next thing is measure of variability or and skewness. So here we look at the how your data is varying from each other. So here we given in example the difference between highest. It's a different parameter, different statistics. Then we can talk about first is the range difference between the highest one to lowest one. Variance is how measure how is spread out the data set in relation to mean. So here like for example, this is the example. We have here mean sorry x value, one variable. We calculated the mean of this x, and then from this value we divided the mean. So this is basically 23 minus 20.3. We divided this, sorry, not divided, subtracted. Okay, and then we got this one, and then we take the square root of this one. We are taking the square of this and then calculating the sum. So this is sum of this. And we have total 1, 2, 3, 4, 5, 6, 7, 7 observations. So a small n is 7. So we have 7, and we know what is the xi, we know what is the x bar. X bar is our mean, and then we calculated the variance. Standard deviation is basically square root of variance that we can calculate. So these are the variance and standard deviation, mean, median, mode are kind of your tool to build a good machine learning algorithm. You should be having good understanding. Like whenever you will get data, these are the first thing that you should look at in your data, like how your data is behaving. um, are you able to find some pattern in your data? What is the mean of this variable? Like suppose if you have many variable like x1, x2, x3, so many variable. So your objective is to look at, okay, mean of one variable is similar to mean of another variable or not, how it is difference, if not then how much it is different from one to another one. So that type of analysis comes under exploratory data analysis, and that is very important and crucial for any machine learning application or algorithm to build model. Okay, and then skewness is basically it talks about the shape of the data, means how your data is look like. You have the data, you can draw your, you can create a graph of your data. There is a term called normal distribution, Poisson distribution, different type of distribution, means how your data behaving. So like if you draw this data, whether it is kind of creating a bell shape or it is looking like a something like this. So different type of shape. So for example, if it looks like this, so here your mode value, you remember what like we discuss about the mode. When you have the highest value, any number that is occurring more number of time, here is the frequency. So for example 2 is coming more number of time, the mode will be more, then median, then mean. In a symmetric data, when your data follow the normal distribution, your mean, median and mode all will be equal, and we will call it normal distribution. When you have negatively skewed, then your mode will be more, and when you have positively skewed data, then your mean will be more compared to median and mode. Okay. Another thing you should be knowing to build any machine learning model is correlation and regression. So, excuse me. So, correlation is basically finding out relationship between different variables. So, like for example, here we have weight and systolic blood pressure. So, in general, we know if someone weight is more, so blood pressure may go up, or any variable, like for example, your level of education and your income. It will be like if you are highly educated, you will earn more. Or for example, if your age is more, your weight may also more. Not true in all the cases, but in general, that's the situation. So we uh, analyze the relationship between different variable. When we will get the data, first thing that we should look at the mean, median, mode, the distribution of different variable, and then another concept comes in picture is the correlation and regression. So we look at the whether these variables are correlated or not correlated. If correlated, then they are positively correlated or negatively correlated. So like for example here, if our weight is increasing, here weight is increasing, so blood pressure is also increasing. Okay. So then we can draw a line here. Okay. So and we can say if weight is increasing and systolic blood pressure is also increasing, it means the weight is helping or predicting the increase in systolic blood pressure. That means it is a positively correlation, positive relationship between these two variables. And regression is nothing but to fit this particular line, how well we can fit. So there can be a multiple line, multiple straight line. We can have this line, we can draw one more line, we can draw one more line, we can draw one more line. So which line represent the best of your data to develop some model is all about regression. So like for example, here the best fit, suppose this is the best fit, and then we have in future we will be having weight, and from weight we can decide. So we got some pattern, this is the pattern. So here for example, someone weight one person weight is 140 kg. That's very unrealistic, but let's assume. So if someone weight is 100 or 140 kg, then what will be the systolic blood pressure? So with the help of this variable, we can predict the systolic blood pressure. This is all about the regression. And this is the foundation for machine learning. Using or analyzing the relationship between two variable, we are predicting what is going to happen in future. Okay. So different type of correlation. So we talk about like this is the positive correlation when X and Y increase together. This is negative correlation because here X is increasing but Y is decreasing. Means if your X is here, then Y is also here. Means it is behaving in a different way, not like this one. And if we do cannot find any pattern like this, it is not increasing or not decreasing, then we can say there is no relation between these two variables. By default, if you are running, if suppose if you have some one variable, variable one and variable two, you don't know anything about the what is this variable. So like in the previous example, you know if weight will increase, so blood pressure will also increase. But suppose if you don't know about the variable, then you have to find out, you have to calculate the correlation coefficient between this and this, and then based on that you will decide there is a relationship or not. By default you will get some value, like there is a formula. If you are putting all those variables and calculating, using that formula and calculating the correlation coefficient, you will get some number, but that won't make sense. Okay. And when we say yeah, I'll talk about the curvilinear. uh, okay. So when we have a linear relationship between variable, we say it is a linear regression model. We will build the linear model. Here we can see there is a line. We can see there is a line, whether in this direction or in that direction. So and if our all the values are close to this well fitted line, then we'll say a strong correlation. And if it is not very close to this well fitted line, then we'll say it is a weak correlation. Okay, curvilinear is basically when we don't have any straight line. Here it is a curved, it is not a straight line. So the relationship between x and y is not a straight line. While initially, see, when x is increasing, y is also increasing. But after here, till here, x and y increase together. But after that, you are increasing your x, but your y is decreasing. See here. Here x is increased, but y is decreased. So this is not following the linear relationship that comes under curvilinear correlation or curvilinear relationship. Okay. Okay, so some questions. So regression is a statistical method used in finance and investing. Yeah, so regression is a statistical method that we can use in any field. We can use in finance and in pharma domain while developing some medicine, or in marketing, or in manufacturing, automotive, anywhere we can use. Okay. So how to calculate the correlation and how to get some value. So correlation coefficient is basically it's a statistic showing the degree of relationship between two variables. If value is more, then we'll say that it is highly correlated. If value is less, then we'll say it is not very highly correlated. And it ranges from -1 to 1. If it is minus, then we'll say negatively correlated. If it is plus, then we'll say positively correlated. So sign denote the nature of association and value denote the strength of the correlation. So let's see one example. So like this is a serial number. The difference, we have 6 observation. We have the age of a student, and we have the weight. So we know if age is increasing, weight will also increase. Means there is a positive correlation that we can guess. So how we can calculate? So we know there is a positive correlation. So after calculating this correlation coefficient, we should be having some positive correlation value. So so this is our x value and this is our y value. Then we multiplied x and y and we got this xy. We also calculated the x square and y square, and here all those sum. And then we have all those numbers like summation of x and summation of y, summation of xy, everything we have. We put all these statistics, all these numbers here in this formula, and we'll get a correlation coefficient. So see here, it is a positive 0.759, that is positive strong correlation. So anything is greater than zero point 0.6, zero point 0.7, we can say it's a strong positive correlation. If value is zero point 0.9, then it is highly positively correlated. If value is zero point 0.2, then we'll say it is a positively correlation, but not very strong, weak correlation. Okay. And here the range is -1 to 1. For few cases, it can be negatively correlated also. Okay. Then simple linear regression model. So we talk about how the variable is related with each other. What is the regression? So little bit more about the regression. So regression is the process for explaining the relationship between dependent variable and one or more independent variables. So like for example, we talk about if we have only one independent variable, that is size of the house, and we are predicting the price. That is simple linear relationship. But if we have more than one independent variables, like here in this case we have two, 1 and 2. So this comes as a multiple linear relationship. And not only two, we can have many independent variable, maybe more than 100, 200, or sometimes thousands also. And using all those hundreds of variable, we are predicting the price. And if we have more number of variables, that will almost always helpful to build a better model, because the price may depend on other factor also. Like here we are predicting, we are saying the size of the house and number of bedroom, and then we are deciding the price. It is also possible that the location matter, like maybe this this particular house is in city, then it will be more expensive compared to other. So there can be many more variables. So if we have more number of variables, then we will be able to develop more robust model. And it's basically relationship between x and y. So x is all these are x, and this is our y. And now the question is, if both talking about the relationship, then what is the difference between correlation and regression? So correlation describe the strength of relationship between two variables, okay, between the variable linear means, while regression model estimate the nature of the relationship for dependent and independent. From correlation you can get an idea, okay, these variables are positively correlated or negatively correlated, but you cannot predict what is going to happen in the future. So for that, then regression analysis comes in picture. And we all know that the very line equation, simple linear line, is y equal to mx plus c. If not, then you will read soon. Okay. So here, like we have x and y, and we have intercept, and we know this what is the slope. So for example, this is the, if we just complete this line till here, okay. So here we say that this is the x. Now the question is, this is x, and if we just look at this point, at this point means x is 0. So x is 0, but still we have some value. Okay, so that is basically intercept, means for any house we will be having like x is 0. If we just talk about only this particular, suppose this variable is not available, let's, for the simplicity, let's consider we have only one x and one y. Okay, so x is 0, but still we have some price. This is about the price. Why? Because uh, here this is wrong example, because x cannot be, means the size of the house cannot be 0. It may be some other variable. Let's consider some other variable like location, or a number of bedroom, or or any other variable, like not coming in my mind, but any other variable. uh, that value may be 0, value may be 0, but still we have some price value. Here x, we are talking about the um, size of the house. The size of the house cannot be 0. Okay, we can consider this like number of bedroom. If it is 0, we have the house, we don't have any bedroom. Let's consider this is and means practically it is not going to be happen, but just for simplicity, just for the example, we have the area. Then what will be the price of the area? Will be having some number here. And if we increase the bedroom, then it will keep increasing accordingly. So that is the reason we will be having some intercept here. And for the different values of x, we will be predicting the y value, price of the house. Okay. So enough about center tendency and variability and correlation and regression. All these terms we will be using to develop any model. Any model means if we are developing the linear regression model, so uh, linear regression model, then we have to use all the continuous variable. Our dependent variable will be the continuous. If we are developing a classification model, then our dependent variable will be a categorical, either class 1 or class B. Okay. Okay, there is uh, Gradient. Okay, so there is, okay, good. So you guys are okay. So I'll just go back a little bit. There is a question about the gradient. So there is a different approach or different methodology to estimate. So one is the least square estimate to get these values of different coefficient, the coefficient of the regression line when you will build the model y equal to constant plus beta 1 x1 beta 2 x2. So beta 1 is nothing but your regression coefficient. So different methodology to estimate. One is the least square estimate, another one is the based on the gradient descent method. So gradient descent method we use, I didn't explain here because we were just talking about the basic things, but it seems you guys have some knowledge about the gradient descent. So when we will build the regression model, we'll cover the gradient descent approach as well. We use the partial equation like dy by dx, and objective is to minimize like the different uh, at the different point of time how we can you utilize the concept of minima and maxima, and get the best value to minimize, basically to minimize the error. Okay. Okay, so now little we discuss probability theory. So probability, I think you all know and using in our day-to-day life. Generally we talk about what is the probability of rain is going to happen today, or what is the probability that someone will get a job or not. So probability, again, it will depend on so many factors, but in general in our day-to-day life we use probability very extensively. The formula is favorable number of cases divided by total number of cases. So we all know that uh, tossing a coin, and what will be the probability of getting head. So if you're tossing a coin, you can get either head or tail. So your favorable number of cases here, a is head, so this will be 1, and total number of cases means it can be head and tail both, so it will be 1 by 2. Similarly, for the dice case, getting a 2, probability of getting 2 is 1 by 6. So different type of experiment and different outcomes. So here, toss a coin, you will get head or tail. Inspection of a particular part, suppose you are building a model and trying to predict this particular part will be defective or not defective. So here you will be having output of defective and not defective. Conduct a sales calls, then your outcome will be whether that person will purchase or no purchase. Roll a dice, we already discussed, it can be any number between 1 to 6. Play a football, either you will win or lose, or it can be tie. So 3 outcome possible. Okay. Okay, another important concept is population and sampling. So most of the time we cannot analyze the whole population because it will be a very expensive, very much time consuming. So for that we draw a sample and then do all the analysis, and then prove that if our algorithm or our analysis is working fine for the sample, then it will work for the entire population. So for example, right now the world pandemic COVID-19 is going on. All the big pharma companies are developing vaccines or drug. So there is a sequential process to develop any vaccine. First they have to do research in laboratory, and after doing rigorous research they will get some conclusion, okay, this particular API means one kind of drug is working. So then they will go and do testing on animals, first small animals like rat or cat, and if result is positive, then they will do on a small sample size. A small sample size maybe 10 or 15 human being, to check whether their medicine is safe or not. So when it is safe, everything is fine, then they will go for the phase 2. So phase 1 is just for the safety, phase 2 is safety plus efficacy. In phase 2 they will look at the safety also, and objective is to look at whether this particular drug is working also or not, to cure any particular disease or not. So efficacy and safety both. So in phase 1 they generally randomly select 8 to 10 human being and do the procedure. For phase 2 they go for a little bigger sample, maybe like 200 or 300. Phase 3 they will go little bit more bigger. So the idea is to develop a vaccine for the entire world, for the entire population, but they cannot do the experiment on the entire population. So they have to draw a sample, or they have to select a sample from different locations or different age group, child, human, adult, anything, male, female, country, and then do their analysis. And when they are confident enough that their drug is working, then they will replicate, or they will say no, this will work fine for entire population. So to conduct this, we draw a sample, and for the entire population we won't be knowing the parameter, like what is the mean value, what is the deviation of the different values in that population. So but if we draw the sample and we collect the data, then we can analyze, and idea is to replicate this sample information to the entire population. So basically our sample should be representative of entire population. So there is a different way to draw the sample. We cannot just randomly draw a sample from the population. There is a different algorithm to draw a sample, like simple random sample, with replacement, without replacement, systematic random sampling, stratified random sampling. So one example I can see, like for example, in your school, you want to measure what is the average height of a student. Okay. So if you just draw a sample from uh, 10th grade student, so definitely your average height will be more if you draw a sample from first grade student, because their age, definitely they will be a height will be lesser compared to 10th grade. So, and if you just draw a sample from the 10th grade and decide the whole school average height is 4 feet, that will be wrong. So there you have to use the stratified random sampling approach. Means from each strata, from each class, you draw the sample first, we call it stratum, and then do the next procedure. So sampling is another different field in statistics, and lot of algorithm, lot of approaches like purposive sampling, subjective sampling, and systematic random sampling, stratified random sampling, the different approach that you will read in future, definitely, I'm sure. So this is another field. Nowadays, like in the real life, the good part is we have more computing power. So everyone talk about the big data. So why? Because now we have more computing power, we have more capacity to store big data. So it's kind of little easy for us to analyze the bigger population compared to just uh, compared to earlier time. Earlier we were not having that computing power. Now we have a big CPUs and GPUs, so we can run a huge amount of data and get the more accurate result, build more robust model. Okay. Okay. So now hypothesis testing and inferential statistics. So hypothesis testing is basically, it's a process of deciding statistically whether the finding of an investigation reflect chance or real effect at a given level of probability. So like for example, Okay, so I'll give example in the next slide. So there is a different steps of hypothesis. First, we have to form a null hypothesis. We have to decide what is the null hypothesis. We have to decide the alternative hypothesis, identify the level of significance, test statistics, p-value, confidence interval, and then final conclusion. If you're not aware, if you are not catching up all those terminology, don't worry. You will learn over the period of time, but at least you will get some sense what these terms, if someone is talking about hypothesis testing, you should be not completely blank, so you will have some idea what is hypothesis testing. So it's basically we um, uh, like for example, our objective is to compare two particular drug, like drug 1 and drug 2. Okay, so we can say that our null hypothesis means our assumption is drug 1 and drug 2 is working exactly same, and our alternative hypothesis is no, drug 1 and drug 2 is means drug 1 and drug 2 are not exactly same. So these are the chance. So first we decide what we are going to achieve. Our objective should be clear. Then we define the null hypothesis. Altern.
Hello, Mr. Raj.
Yep.
Oh yeah, we have less than 5 minutes to go.
Oh, okay. I'm right.
Sure.
Okay, I'll try to be fast.
Uh,
Okay. Yeah. So 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 then null hypothesis and identify the level of significance, whether 5% or test 10%, and we should be knowing the probability value, the p value, and confidence interval. And then we have to use some kind of statistical test like t-test or chi-square test or any other test to decide whether these differences are not by chance, it is based on some factor. So here one example. I'm almost done. 5 minutes is fine. So inferential statistics. So for example, we have the population of first grade children, and we adopt two different method for the teaching. This is one sample, and this is another sample, sample A and sample B, and we calculate the average value. So for this particular sample, our average value is 76, while for this sample our average value is 71. So if we just look at 76 and 71, we'll say that method A is more effective compared to method B. Method like this is the teaching method maybe um, extra time, means this population is getting extra time, or maybe morning teaching, evening teaching, or different teachers are teaching, so different methodology. We can assume anything. Our objective is to statistically check which method is better compared to other. So if we just look at the number, we can say this is better compared to this, but that may happen by chance in the sense whatever sample we collected in this and whatever sample we collected in this, maybe these students are intelligent more compared to this, so then teaching is not playing a role. A student are already brilliant compared to this group, so that is by chance, this happened by chance, there is no impact of teaching. So we, we should be having enough evidence to say that method A is better compared to method B. For that, um, we draw means we follow the steps and do the inferential test, like first null hypothesis, alternative hypothesis, and we analyze the data also to get the mean value, and then apply some test. Like here in the null hypothesis, mean 1 and mean 2 is equal, and alternative is mean 1 is not equal to mean of 2. And objective is to reject null hypothesis. So based on the p-value, if p-value is greater than, sorry, if p-value is less than 0.05, Then we'll say null hypothesis is rejected, means alternative is accepted, means mean 1 is and mean 2 is not exactly same. It is not by chance. There is a some factor driving that. Okay. Okay, so I'm done, but I wanted to cover the coding part also, but we'll cover in the next session.
Thank
Okay.
you, Dr. Rad. But you can cover the coding section. I don't know if our students you can cover the coding section.
Okay, I can go ahead.
Yes, you can go ahead.
Okay. Okay, great. Okay, so, okay, are you guys able to see my screen?
Yes, we can see your screen.
Okay, great. Great. So, um, this is Jupyter Notebook, and we will be using the Python. So, I know that you are learning Python, and we will be also using Python. This is the sample dataset, Boston housing dataset. This dataset is available online. Online in the sense when you install some packages on Python, these dataset is already available. Means no need to download from anywhere else. It's already in the package, so you can look at the data. I'm not sure how much you have learned in Python, but just to don't worry about that. It will give you a brief idea. So uh, to do analysis, first we have to install few libraries. So here we are using the Python library, C1 library. These are the libraries for the visualization point of view. Pandas is basically for the analysis. NumPy is again for the analysis, mathematical analysis to calculate anything. And the method is simple. Like for example, first we have to install. So we use pip install and then package. Pip install and then package name pandas. Okay. So first we have to install the packages. Once package is already installed, then you have to just call it. So we have, I like in my case, I have already installed these packages. I'm just calling those packages. Like scikit-learn is another library. Scikit-learn is another very popular library for building machine learning models, especially for the regression model and tree based model. Okay. And we have some data set. As I said, like we will be using the Boston housing data set. It's already available in this package. So I'm just loading that data set here. So data set is loaded. We can see what are the values, means what are the features is available in the data set. In the data, it contains the information of various houses. Our target variable is the price of the house. Features is the name is different. What is the different uh, feature name basically here, and describe the data set. So different variables, like in data set, we have the different variable. One variable is Creme and Gian, Indus. So these are the different variables. You can read what is the different variable. We are interested for target variable, means what is our target variable and which independent variable we should select to build any linear model. So this data set is in different format. So for our ease and for our analysis, we can convert that data set into data frame. So here we are converting, we are using pandas. PD is panda. Basically here, if you see, import pandas are PD. So we are using PD to convert that data into data frame. So, and here we can, head is basically to look at the data. We can change here number, like for example, if we want to see the first 10 row, then it will give the first 10 row, or 5 row, 3 row, whatever we want to look at, it will give. We can see head and tail both from top and from bottom also. So in this data set, we have all the independent variable, but we don't have target variable. So target variable is here, this one, MEDV, that is price of the house. So we added this also. After adding, now you see here, this is the target variable, the last column we added in the target as target variable in the data set. So whenever you get the data, before building any model, it is very, very important to analyze your data first. Means to do all the exploratory data analysis. Means look at how your data look like. Do you have any missing cases? How many unique numbers you have? Unique number is useful when you have some categorical features. For numeric, it is not very important, but still you can look at. Do you have any missing? What is the count? All those things. So you can create a and also the type of the data. So like here, this is float. All in my case is everything is in float. We may have a string, we may have a date, we may have some other type of features also. So this is just a look to, like, for each variable, what is the data type, what is the count. And so in my case we have 506 records. And if you want to see how many rows and columns we have, that also you can quickly look at. So our data is, for example, this is our data. So data, and then just type SAPE. So it will give you a SAPE. So we have 506 number of rows and 13 columns. Okay. And then we can draw some graph. Like, for example, our dependent variable is price, house of the price. So we just draw how this is working. So it is, see, it is almost a normal distribution. Don't worry about normal distribution if you're not not aware. We'll learn. There is a different type of distribution. Normal distribution is very, 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 very common. So here we see that this particular variable is distributed normally with few outliers. So like this is kind of normally, but few, like for example, this one is the outlier. So it will give some idea how your data look like. And then also you can calculate what is the maximum value of the price. So here 50. What is the minimum value? That also you can get. What is the mean value? So these are the different different formula Python that you can use and analyze your data. Standard deviation. So if you do in Excel calculate, you have to go through with multiple. Here in Python, it's just one line of code and you will get the value. Also, there is a describe. There is another method, describe, that will give you descriptive statistics for all the variable at a time. So it's now that is kind of, you can consider as homework. You explore this data, do all those analysis, plot graph as much as you can. This is just one variable. You can draw the graph for all different 13 variables. Okay. And okay, so here this is the example of scatter plot. So here I just created a data set. We have x and we have y, and I wanted to plot the scatter plot. So this is x and this is y. So this is kind of negatively correlated. We can see here some pattern in our data set, in our Boston data set. uh, Also we can look at the, so this is our dependent variable and this is one independent variable. So this is between MEDV and LSTAT. This is negatively correlated. And with another variable, with RM, it is positively correlated. So we have to look at all those things. Okay, this is another example is correlation among variables. So we have total 13 different variable. We can just quickly in one line of code, boston.corr.round means from one line of code, we will get the correlation value for the different variables. So, and then we should focus where we are getting the maximum value. So like for example, MEDV, this is our dependent variable, and here you can see negatively correlated minus 0.74. So MVDV, here also we use this one MVDV, and LSTAT, we can see here negative negatively correlated. For this, with RM, we should be having some positive number. So if we look at this one, and where we have RM, see this is RM. Here you see this is positive 0.7. So this is positively correlated. So by looking at this, we got some idea. Okay, RM has a strong positive correlation, where this has a high negative correlation. So we have to focus on these explanatory variable while building the model. Okay, so that's it. And in the next session, we will be using the same data set and will build a simple linear regression model and then multiple regression. First, we will use one variable, then more than one variable. And we'll talk about different approaches like gradient descent approach and least square approach, why gradient descent is better than least square. Everything we'll talk about in next session. Okay, thank you very much.
Thank you, Dr. Raj. This is very interesting. We had a wonderful time. In fact, myself and the just looking at everything. It's very wonderful and very interesting. Thank you for your time. Thank you for your
Thank
patience.
you. Thank you very
Thank
much.
you everybody for staying with us. Although we took some of your time, but I can tell you it's really worth it. I've learned a lot myself. I was telling you this that these are some of the things that we learned during our university days, and we're getting it here. It's very interesting. Thank you, sir, for your time. Thank you.
Yeah,
Very
thank
amazing.
you.
Very amazing.
Thank you. Thank you very much. Bye bye, guys. Happy
But
weekend.
I have any assignment for them.
Yeah.
I don't know if you have any assignment for them, doctor.
Yes. So assignment is just refresh and brush up your basic statistic concept, like understand mean, median, mode, and use this Boston data set. Boston data set and plot graph for all the variables. So like this graph is only for the one variable. You can draw graph for all the variables and see how it is behaving, how it looks like. That is your question, homework.
Okay. Thank
Okay.
you very much, sir.
Yep.
Thank you very much, sir.
Thank you very
So,
much.
yeah, bye, sir.
Bye bye. Take
Yeah,
care.
bye.
Bye
Bye.
bye.
Bye, sir. Thank you. So, we're going to upload the videos and the presentation on our module. So, click on our module and do your assignment and same time submit it at hello@coderina.org. Bye, everybody.